but they are rocking above and below the line of frame. So this is a non-Grashof double rocker with a very good approximate straight line generation between O2 and O4, this coupler point C. This is the model of the Chebyshev's 4-link mechanism, which can generate an approximate straight line by this midpoint of the coupler O2, A, B, O4, and this is the point C, which is the midpoint of the coupler AB. As we calculated the link length ratios, this O2, O4 is twice of AB, the twice of coupler link, and this link length and this link length are equal and is equal to 2.5 times this coupler link length, coupler length AB. If this is unity, then this is 2 and these two lengths are 2.5. If we move this, we should notice the curve generated by this coupler point. As we see that this portion of the coupler point is a very good straight line, very good approximation of the straight line, that is, this is above, this is one configuration that we considered where O2, A and AB are vertical. This is C1. This is again O4B and AB are vertical, and this is C2, the coupler point. And this is the symmetric configuration which we call C, O2, A, B, O4 with this point as C. So this is the Chebyshev's, which is again a double rocker, but as we see the rocking is all above the line of frame, so it is a Grashofian double rocker, unlike the previous three. To a model. This is the model of that Poiseuille straight line mechanism, which has 8 links, the fixed link and 4 links to make the rhombus, 2 links to make that isosceles triangle, and this is the extra link to ensure that this point passes through this fixed point O. This was our O, P, Q, A, B, and this is OPP. As we see, as this mechanism is moved, we will find that this point Q will generate this exact straight line. As this mechanism is moving, the point P is generating a circle which will pass through O. Consequently, this point Q is moving along this straight line. Now, if I remove this center OP from this particular point such that this distance is not the same as OPP, then P will move along a circle, but definitely will not pass through O. In that situation, if I remove this OOP and take it to some other location, then as we see, this point Q is going along this circular arc of very large radius, because all the conditions of inverses is being satisfied. OP into OQ is constant, OPQ always remain along a straight line, P is moving along a circle. Only thing, that circle is not passing through that fixed point because this distance is not equal to this distance. Consequently, Q will also move along a circle. In fact, we are able to get a mechanism such that I can draw circular arc of very large radius. In fact, this circle, the radius is very large. If I had moved this point to the other side, I could have generated this circle. but only when I make OOP is OPQ, the radius of the circle becomes infinity. This is of one curvature, this is the opposite curvature, and this is the no curvature. If I call it positive curvature, negative curvature, and zero curvature, which means a straight line, that is a circle of infinite radius. This is what we call a Poiseuille straight line mechanism, only if I ensure that OOP is OPP through a model. This is the model of the Hertz inverser, which is a 6-link mechanism. As we see, the fixed link, link number 2, 3, 4, 5, and this is the 6th link. These two link lengths are same and these two link lengths are same, constituting an antiparallelogram. The opposite sides of this quadrilateral are same, but that is in a crossed configuration. This is what we call A, B, C, D. Now we take one point on this link fixed. Then think of a straight line which is parallel to this line and this line. Because this is an antiparallelogram, these two lines will always remain parallel. And I think of a line passing through this fixed point O, which is parallel to this line and this line. The intersection of that straight line drawn through O with this link I call P. And this is the intersection of that straight line with this link, which I call Q. Now I make OP is OPP. This link length, this point OP I choose on the perpendicular bisector of these 2 points, such that OPP is OPO. Consequently, P will go along a circle with this point as center and this as radius, and that circle will pass through this point O. As a result, since OP into OQ remains constant, which we have proved, PQ passes through this point O in all configurations that we have shown, so Q will generate a straight line. As we can see that this point Q will generate this straight line. As we see, this point Q is generating this straight line. So this is Hertz inverser, which is a 6-link chain as compared to a Poiseuille inverser, which was an 8-link mechanism.